For experiments 10 and 11, you're essentially using the same tools and techniques. So we're going to use one video to encompass the setup for both of those. And we're doing calorimetry. So we're doing two different calorimetry experiments. In experiment 10, we are investigating how to calculate the specific heat of a solution and metal, an unknown metal. The experiment 11 is determining the enthalpy of reactions, which I always think is really, really fun and interesting to determine whether something is exothermic or endothermic and to actually calculate what that value is. The first step in both of these experiments is calibrating your temperature probe. So first we want to have a lower point. So I have an ice water bath and I've let it sit for a little while to make sure that the water and the ice are in thermal equilibrium, so that water is cold. If I just add it, the water's not quite cold yet. So I want to make sure that some of that ice has melted. And I'm going to enter on the computer 0 for this lower temperature limit. For my higher temperature limit, I'm going to use my thermometer and I'm going to have a hot water bath. I don't want it boiling, but pretty close to boiling. And these bubbles are not indicative of boiling water. These are just some dissolved gases that are effervescing. You'll be able to tell if it's boiling. So to set my upper temperature limit, what I'm going to do is put my thermometer and my temperature probe both in the water. I don't want to set it down on the bottom of the beaker because that's really measuring a much higher temperature next to that really hot plate surface. And I don't want to touch the side of the beaker with either my thermometer or my temperature probe. I want to hold it somewhere in the solution far enough away that I'm not touching the sides or the bottom of the beaker. And I'm going to wait for a couple of minutes, just like with my lower temperature limit. I'll wait probably 90 seconds to 2 minutes, and I'm going to make sure the temperature stops changing before I record it. Close to boiling is good. If you can get 70 or 80 degrees, a wide temperature range is going to be really useful. And once that stops changing, I'll enter in the value on my thermometer as my upper temperature limit. Once I've calibrated my instrument, for experiment 10, you'll be measuring the heat capacity of a solution, and you're also measuring the heat capacity of, or measuring a temperature change and then calculating the heat capacity of a metal object. So I have water in my cup, my very fancy calorimetry tool. Styrofoam cup works great because it's an insulator. It's really effective. So any temperature changes are going to be mostly in the solution, in the liquid, and not due to outside interactions. So I'm going to use my temperature probe. I want to measure the water temperature before I add anything because I'm measuring a change in temperature. So that's my initial temperature. I need to leave this piece of metal in my hot water bath for a couple of minutes. It's going to take a little while to reach thermal equilibrium to transfer the heat from the water to this metal object. So after I've waited several minutes, I'm going to use my tongs. I'm not going to put my hand in there because it's hot. I'm going to use my tongs to pick it up, shake off the water, and immediately put it in my cup. And then my temperature probe, which is still in there, is going to be recording the change in temperature. So after a while, we'll record our final temperature and we'll use that in our heat capacity equation. So that's experiment 10. For experiment 11, we need to be careful because not only, I should point out with our hot plate, this ceramic white surface is very hot. So not only do you not need to touch it, but be careful of all the cables. Make sure there aren't any cables touching the hot plate surface. If you're using your temperature probe over here, make sure that you aren't going to melt the cord. All right, so another word of caution about experiment 11. We are going to be using pretty concentrated solutions of sodium hydroxide, hydrochloric acid, and sulfuric acid. And you know that this is a hydroxide, that's a strong base. Hydrochloric and sulfuric acid are both strong acids, so we need to be really careful here. Make sure you're not wearing your nicest clothes because the acid is corrosive, and we used to joke in graduate school that you could point out a synthetic organic chemist because they had a row of holes in the t-shirt they wore to lab because of all the nasty spills on the counter. And we don't want that to happen to you, so make sure you're wearing clothing that you don't mind if there is some damage to them. Okay, so for this one, I'm going to be really careful. It's really important for this experiment to measure out carefully each of your solutions. So we're going to be measuring the enthalpy of reaction for a couple of mixtures. We're going to measure our amount of sodium hydroxide. We're going to add that to our cup, measure the temperature. I'm going to rinse this out or use a different graduated cylinder for my acid. I need to measure the same amount of acid or I won't have accurate enthalpy of reaction. So the same amount, I'm going to make sure I get down on eye level and record that meniscus. And then after I've clicked Start Experiment, or Begin Experiment, I will combine the two equal volumes of strong base and strong acid. And over time, this will equilibrate and we'll get a temperature reading and we'll use that to calculate the enthalpy of that reaction. So again, be really cautious with the hot plate and the strong acids and strong bases. So that's experiments 10 and 11, all about calorimetry.